In this lesson, we're going to take a look at decomposition reactions, which is when we have one reactant that breaks down into two or more products. Those products can be a combination of elements and compounds. So we can have two different elements. We can have an element in a compound, or we can have multiple compounds. So we'll take a look at each of these. The general form for a decomposition reaction is AB, so one larger compound breaking down into A and B, and these can be two elements, an element in a compound, or different compounds. So if I have a binary compound, that is going to break down into its elements. So for example, magnesium chloride, that is made up of the elements magnesium and chlorine. And so those are the elements that this is going to break down into, so you would need to be able to predict that. And then from there, write chemical equations, so a skeleton equation, and then balance that equation. So magnesium chloride, magnesium is in group 2, so it's a 2+, chlorine's in group 7, so it would gain 1 electron to give it a charge of 1-. So that means MgCl2 is the equation for magnesium chloride. And then that breaks down into, and on all metals we just write as a single atom. And chlorine, we know from Hofbrinkel, is a diatomic compound, or element, sorry, one type of element there. So we have 1 magnesium, 2 chlorine, 2 chlorine, so that is balanced. Another type of decomposition reaction, so something that is a hydrate, which means it has water attached to it, can break down into the ionic compound without the water attached to it and water. And so what a hydrate looks like, so barium hydroxide octahydrate, so the way that we would write that, so barium is in group 2, so it's a 2+. Hydroxide from our polyatomic list is 1-. So as we do our crisscross, that means BaOH2. So that's barium hydroxide. And this is going to break down into the ionic compound, barium hydroxide, and then the hydrate will be the water. So this is going to make barium hydroxide and water. So BaOH2 is barium hydroxide. The hydrate just means water. Octa means 8, and so the way that I show 8 waters being attached to barium hydroxide, so I'm not going to use a plus because that means it's separate. So I'm going to use similar to in math where we can use a dot to signify a multiplication. 8 and water. So this is barium hydroxide octahydrate. And that is going to break down into just barium hydroxide, which we already looked up worked out what the chemical equation for that is, and water. And these are nice and easy to balance because we have the same things, just no longer connected together. So the water is now going to be separate, and I'm just going to have 8 waters to balance that out. The next type of decomposition reaction is where we start with a metal nitrate. So that from our data tables, nitrate is NO3. In terms of a charge, it's NO3-. And that was going to break down into a metal nitrite and oxygen. And we haven't gone over the naming yet, but anything that ends in ate, to become an ite, it just loses 1 oxygen. So instead of NO3, nitrite is NO2, and the charge remains the same. So it's still a minus, like it was in nitrate. So as an example, potassium nitrate, so potassium is the metal, so the nitrate breaks down into that metal's nitrite, so potassium nitrite. and oxygen. So for equations, potassium is a 1 plus. So I have a K plus and an NO3 minus, so 1-to-1 ratio there. So KNO3 is potassium nitrate, and that is going to break down into potassium nitrite. So once again, K plus and then NO2 minus, so same 1-to-1 ratio, but NO2 this time. And oxygen we know is one of our diatomics, O2. So to balance this, I have K and N, 3 oxygens, and 4 oxygens on this side. So this only comes in groups of 6. So if I have 2 here, that would give me, or sorry, groups of 3. So to get 6, I could have 2 potassium nitrate. That gives me 6. And to balance out my potassium and my nitrogen, these are the only places I find them, and I have 1 and 1 in each potassium nitrate, 1 and 1 in each potassium nitrite, which means whatever I have over here, however many molecules of potassium nitrate I have, I also have to have that many of potassium nitrite. So that will always balance my potassium and nitrogen. So here I have 6 oxygen, 4, 5, 6, so that's balanced. Second last one, so a metal carbonate is going to break down to a metal oxide and carbon dioxide. So from your table, a carbonate is CO3 and has a charge of 2 minus, and then metal oxide is just a metal with oxygen and carbon dioxide. So for example, zinc carbonate. So the metal oxide for that would be zinc oxide. And then carbon dioxide is the other product made there. So zinc is a 2 plus. And carbonate is a 2 minus, so 1-to-1 ratio there. So zinc carbonate. And oxygen is also a 2 minus, so 1-to-1 ratio again. So ZnO is zinc oxide, and then carbon dioxide. So I have 1 zinc, 1 carbon, 3 oxygen, 1, 2, 3 oxygen. So this is balanced. The last type of decomposition reaction we're going to look at is a metal hydroxide breaking down into a metal oxide and water. So hydroxide from our polyatomic table is OH minus. So potassium hydroxide, so becoming a potassium oxide. And water. So potassium is K plus, so 1-to-1 ratio KOH. And oxygen, on the other hand, is a 2 minus, so K2O is potassium oxide. And water, H2O. So I have 2 potassium here, only 1 here, 2 hydrogen here, only 1 here. So that takes care of both potassium and hydrogen. That leaves me with 2 oxygens, and I have 2 oxygens, so that is now balanced.